Welcome to another coding session. Today we're going to be programming the Pico to access the BNO to send data back to the phone through an HM11 to send data back to a servo through an NRF 24. So these two already have code for it. I'm going to create the code for this one. We're also going to add calibration code and a way to save it to memory on the Pico and retrieve it whenever we power up. So uh, I'll show you a close up on how everything is connected. Let me just rotate it so you can see how the wires go. So we have power, ground, and then SCL and SDA, and the last two pins is the boot that is connected to ground through a switch, and the reset. I'm sorry, the boot connected to power through a 10K resistor, and the last pin is the reset connected to a switch to ground. So, so the way it's connected, um, the BNO is connected to GP15 or pin 20, which is the SCL, and the 19 to SDA or GP14. So this is what it looks like. So we have power here. That's the reference. I have this backwards, so just you can see it as a reference. So power, ground, SCL, SDA, and then we have the boot connected to power, 3 volts coming out of the Pico through a 10K resistor, and then the reset pin connects to the switch, which pulls it to ground as well, and is the same pin that boots the Pico for resetting it. And on this side is just this is the NRF. So we have on pin 16 we have the master in, master out, clock, CSN and CE. So it's this one's here. It starts on 16 or GP12. So this is the master in, master out, the clock, CSN and CE. Okay, and so we're going to be using this data sheet from Bosch, I guess how you say it, is the BNO055. So let's start programming it, and we're going to continue with the previous project. We're selecting the same Pico HM11 project. This one has the images here, that's why you have these extra files here. This will be uploaded for you to download. So let's start by adding the requirements, since we are going to be writing to Flash and using I2C to communicate. So we'll add a file under source, and we'll call it BNO55. This will be for the class. It will be .h. And before we add any code, we need to make it accessible. So we'll go to the CMake lists txt file, BNO055 .h. And then we'll add the required libraries. One is I2C, and the other one is SPI Flash. Okay, so we're adding those two. We'll go to main. What's this? And under main, we'll add the SRC. Actually, we'll add the libraries first. So hardware I2C and hardware Flash, and the SRC BNO, and that should get us going. So now we can go here and create the class. Before we create a class, we're going to add this just to make it easier. We're going to add this too, just so we have access to the header files. So we'll add it to the top of the file, and now we'll create the class. We'll give it with the name of the file, which is BNO055. And here we'll start adding the code. We'll need private variables, public as well, and public functions. Okay. So for the variables, to initialize the I2C, we need a pointer to or an instance to the port. So we'll call this port, and it will be a pointer. We also need an address. Oh, that's not good. Okay, and we need 16-bit for the pins. So the SDA, 16-bit integer, and SCL. We're also going to need helper variables, so we'll need a value and an array of 22 bytes because that's the calibration data size, 22 bytes. Okay, so now we overload this function here, the initializer. So we'll rewrite that one, and we'll add the port. And the address, the SDA, and the SCL. This class is gonna communicate with this, and what I'm trying to do here requires a lot of functions, so we're gonna do a few at a time. Let's do 3 at the beginning. So let's start with reading and writing to the unit register. So we'll read a register, and we'll call it reg, and the data and the size of data as well. So we also need to write to it. The signature is the same for the function. So let's go create this string. Okay. And we'll copy this. Let's format it. Okay, so the first one is just getting the pointers and initializing I2C. So we'll start with port and address, the SDA, and the SCL. Okay. We need to initialize I2C. So this requires a port and a baud rate. So we'll use 100,000 or 100K. Okay. We need to specify the function for the pins. So set function SDA will be GPIO I2C, and we'll do the same for SCL. CL. We need to what else? Pull up. So we need to pull up the SDA and GP pull up the SCL pins. So that should be all we need for initialization. Reading a register should be, it's a two-step process for in this specific platform. So it's I2C. We're going to write using blocking. This for simplicity. Obviously, you wouldn't want to use this on production code because it will hang if something goes wrong with your unit. It will just stop responding. You want to put a timeout on it. So we are writing, this requires a port and an address. we have those two. And now the source of what we're writing is in red, and the length will be 1, which reminds me let's set um, defaults here. We'll set 1 and 1, so we don't have to put that in there. Oh, for this one we still do. Sorry, size of data. Size of data. And it's asking us if we want to put a no stop or stop, so we'll say true. We want to hold the line because we're still reading. So we're going to now read the data we're after. So this requires a port, an address, and then where we're going to store the data. That would be under data. That's the parameter we're passing. And then the length will be size of data. And now we can say false. So release communications with the unit or the device. Writing will be in one step. We'll just use write blocking, but because it requires a register and we're getting a register and the data separate, we'll need to declare a buffer, local buffer here, with the size of data +1 for our register, and we'll initialize it to the register. Okay, and we use memcopy to move the data into the buffer. So we want to advance the pointer 1 because we don't want to overwrite the first byte, only the last bytes. And we add data and size of data. And now we can write. So we'll write to the port using the address we have, and the buffer size of data +1, and then we'll say false. We don't want to hold the line. So that's it for reading and writing using I2C. Now we need to be able to configure the unit. So we'll well, before I write code, let me explain something here. So the unit, we're going to be switching between configuration mode and NDOF or sensor fusion mode. We need to be in config mode whenever we're making changes. Either we're reading calibration, we're uploading save calibration, or we want to reset the unit. It needs to be switched to config mode. So the operation mode register needs to be changed to 0 if it's configuration mode, or 1100 if it's sensor fusion mode. So the operation mode is 3D, this one here, that's the register. So we'll say enable config, that's one of the functions. Enable NDOF, that's for sensor fusion, and we want to reset this unit. And for testing, we'll add one more. We'll get all this data. This is another function just to read data. And when we read the data, we want to store it somewhere. So for now, we're just going to get the roll, just a regular int. Okay. So let's go do this for. Okay, we'll copy this. Okay, we'll do this one first. Enable configuration. So we'll use our local variable called value, set it to 0. And now we can start using these two functions, the read and write. So we write a register, and the register we set was going to be 3D, so 0x3D, and we'll write the value. Okay. The other thing is that whenever you switch from configuration mode to any operation, there's a 7-second delay, 7-millisecond delay. And from any operation mode to config mode, there's a 19-millisecond delay. So we have to wait 19 milliseconds for this to take effect. So that's for enabling configuration. The next one is similar to that one, but the unit I'm using, if you look here, these two pins are soldered together. So that means that the external clock, it's enabled and it's address 29 as well. So we want to use the external clock because it's more accurate than the internal clock. So to utilize the external clock, we use this register 3F, and it has three bits that we're going to use. It has this one for resetting the unit, and it has this one for resetting the interrupts, and this one for selecting the external clock. So we're going to use these two when enabling NDOF bits 7 and 6, and 5 for resetting the unit. So this is enabling that one. So value, we'll start by enabling the clock and resetting the integers. Okay, and now we write to, we setting was 3F, and we write value. Then we do value again, and we'll this is for NDOF. That's too many zeros. There we go. And this will be 3D. Now we're changing the configuration mode. Value, and here's where the delay comes in. So we have to we're switching into from configuration to this one. So 7 milliseconds delay. So we'll wait for 7 milliseconds. Okay, that's it for that one. Resetting the unit is, they're all similar. So first we enable configuration. Now we're making use of the function we created up here. Value will be B001 is a third bit from the right, if you guys remember. It's this one here. So 1, 2, 3, reset. Okay. Then we write register, and that against 3F. And value, let's let it. And when we reset the unit, you can use the status register to see if the unit is fully reset or it has boot up. But instead, we're just going to use a timeout. It takes about 500 milliseconds, so we'll wait 600 just to be on the safe side. Now getting data, the data we're after, we're going to be getting degrees or Euler angles. So we'll get the heading, roll, and pitch, and each one comes in 2 bytes, starting by 1A. So we'll start at 1A, get 6 bytes, and then we'll get the middle 2 for the roll, and you'll see that the first byte is the least significant, and then the last 8 are the most significant. So let's see, read register, and we say it starts at 1A, 0x1A, and we'll put it in a local variable data, and it's going to be 6 bytes. So now to get the roll, we just say roll equals, it will be converted to a regular integer data. So it would be, this is 0, 1, 2, 3. So we go after our most significant byte first, or bits. So that's 3. And then we shift that. After it's been converted or cast to an integer, we shifted 8 bits to the left. And then we add to the first 8 bits, we add the least significant bits. So that's data 2. And once we have that, we do a casting again to 32 byte or 32-bit integer. And last, the conversion here. If you do degrees per second, then you divide your result by 16, If you do radians, you divide it by 900. So we're doing degrees, so we'll just divide by 16. Okay. So that's it. We could test this code, but it's a lot of coding still to go. So let's just keep pushing through. So what do we do next? Now that we have the configuration functions, we can reset the unit here and enable NDOF. Okay. Let's add some memory functions to manage memory. So we'll add a read memory, and this will be the data, and then size of data. Okay, we need one more same signature, so this will be for writing. And for this one, we'll go to their documentation and we'll use this as an example. It has 3 functions. We're going to use 2. So if you want to write data, you have to write in chunks, but you have to erase first. And the erase chunk is bigger than the write chunk, or the section of data. So for erasing, you have to erase in multiples of 4K. And for writing, you have to write in multiples of 256, but this has to be in alignment with 4K. Okay, it's confusing, but that's what we have to do. So this is what we're using as a target base. We're not going to use a quarter of a megabyte. We're going to use half a megabyte. So we'll multiply 512 by 1024. So let's add a private variable, and let's just add an int32. And this will be the base. So we'll call it flash offset, and it will be 512 times 1024. Okay. We also need something like this, where it'll tell us it's an address or a pointer to the memory address where we make our changes. This is just the base, so we can start there. We can assume it's 0. So for this one, we'll just call it flash contents, and this one will be flash offset. Okay, that should give us the offset and the contents of what we need. So now we can go define these 2 functions. We go to the bottom, copy this. Let's see. So reading from memory is very easy. As you just read from the pointer. So, but when we read it, we're going to put it in data. So we want to make sure that the size doesn't go over the size of what we're trying to accomplish. So let me go back and add variables, because this is for saving settings for this thing. So we need a variable called memory settings, and this is just for keeping calibration and other flags that we might need. So let's call it 32 bytes. We need 22 for calibration and other ones for miscellaneous stuff. And then we want to keep track of the size of that. So size of settings equals size of memory settings. Okay. So now if I go to the bottom here, because we don't want to access more than the 32 bytes or whatever size that is, we're going to say size equals size more than size of settings. Then we say we override it with size of settings. Size of settings. Otherwise, size is okay. And then we copy. We're going to copy into data. We're going to copy the flash offset or contents actually plus sorry the yeah, so the contents and this is going to be from the offset slash offset plus the hold on, what am I doing here? So I'm copying into data, we're copying the contents, I got a little lost here. Well, how does this function work? Mem copy. We have a destination, which would be data, and then we have a source. Let's see how that one is defined here. So the source will be the flash contents, which starts right there, and then it requires an int and a size. Okay. The contents. Oh, I'm sorry, that's the wrong function. No wonder I had too many. It's a single C, not two of them. Okay. All right. So, man, that's confusing. So data, and then we want the source. So flash. Not offset, but contents. Okay, and then we want the size. So this will be, oh, I know what we're missing. We need to specify where we're writing this from. So this shouldn't be size of data, it should be location. And we're going to start at 0 as a default. We're doing the same thing twice. Size and size of data is the same thing. So, so now location. So it's going to be the flash of contents plus location and the size. And that should be it. For this one here, we have to do this line as well. We want to protect the size. We don't want to go over the 32 bytes. On this one, because we can only read and write in chunks, and we only have 32 bytes, we have to read the data first, make the changes, and then write, but write to a whole page. So first we read the settings, and we'll put it in memory settings, our local variable, and we'll specify the size as the size of settings, and the location will be a 0. So once we have this, we can populate we can assume that this is our memory, and we'll populate this data into memory with that size and at this location. This is incorrect as well. So for that, we need a loop. We can do a memory copy, but we're going to do a loop on this one. So it will be index 0, index less than size, and index increased by 1. Since we're going to be using location and we don't want to go past 32 bytes, we'll say location equals location. If it's more or equals to size of settings, then we'll use size of settings, otherwise we'll use location. And now we can say memory settings location plus plus equals data, the data we are writing in index. Okay. And now we get to use these functions here. The first we gotta erase, so we're gonna use that one. Flash range erase. And for this one, it requires an offset, so we have that offset and then it requires the size. So it goes by 4K. So like we can just write this there, or we can say flash is a sector, right? So it's, if you see one sector, so that's one sector 4K. So sector size. Then because we need to write in 256 bytes, I will create a buffer, and this will be the flash page size. We'll initialize it to 0, and we'll copy. So we'll use memcopy, this one, and in buffer, we'll copy the memory settings, and it will be the size of settings. And after that is done, we'll program it, and it requires a flash offset, and the data and the size will be flash page size, because that's the requirement. Okay, and that's it. Let me compile. Make sure there's no errors, since that's a line of code. Even if it compiles, doesn't mean that it's not going to have errors. You know, there may be some logic there that may be fuzzy. So it compiled, is good to go. Now let's add the calibration code for this. So we'll need let's add also a few variables here. So this one will be heading, and this one will be pitch. So for calibration, we need multiple variables. One is as a flag to calibrate this thing. So we'll call it calibrate, and it will be initialized to 0. And then we'll have another one that will be called calibration data, and that will be initialized to 0 as well. Then we need the calibration components. So each of the components, calibration stat. So this register 35 has 4 components, 4 bits each for calibration. So it can have a status of 0, 1, 2, or 3 for magnetometer, accelerometer, gyro, and the system itself. So we need to get one of each of those components and pull them aside on a variable. So we'll use the mag first, and we have 4. ACC, gyro, and system. So we're good there. Now we'll use this flag for calibrating it. Let's go to get data, this one here. And while we're adding it, we'll get the other two. We'll get the heading and the pitch. And it starts at 0, 1, 2, 3, 4, and 5. Okay. So now for calibration, we'll check if the flag has been sent to calibrate. So it's calibrate equals 1. If it is, that means we want to calibrate. So we flag it as to 2 as a way of saying, okay, we're calibrating now. We want to reset the BNO and enable NDOF. So it's resetting it and setting it right back to it. So it's going to wipe out the calibration or whatever it has, and it's going to start like if you were booting up. So once we have it at 2, we need something else here. We need to read the calibration data. So let's read the register, and it's 35, and we'll put it in calibration data. Okay. So when it's fully calibrated, all of the components will be 1, which will make the entire register 255. So we can say if calibration data is equals to 255 or XFF, then we have calibration, right? So at that point, we can say we're calibrated, and here we want to enable configuration, because we want to read the calibration data and it has to be in configuration. So we say value, and it's just going to be a 0. No, what are we doing? No, we're reading the register. So we are reading the calibration registers. So this registers, it's 22 of them, and it starts at 55. So we'll read 55, put it in data, 22 bytes. That's our calibration. Then we can write to memory to save it, and we're writing the data, 22 bytes, and it's going to be allocation. We're going to use the last 32 from the end of the 32 bytes backwards to store the calibration data. So we'll use size of settings minus 23 because it's 0 based, and then well, let's say value, and this one will be let's set it to 1 for flagging it as calibrated, and then we'll write to memory value, size of 1, allocation, size of settings minus 24. So it'll be 1 byte before the calibration data starts in memory. And now we enable NDOF, and we should be good to go. So in this function, in NDOF, whenever this one is called, since it's called when it first powers up, this is where we check if we have good calibration in memory so we can load it. So we'll read the memory. So read memory, and we'll put it in value. We'll read location, size of settings minus 24. And now we can check if value is equals to 1, and we are not calibrating. So calibrate equals 0. Then we can read memory, and we'll read 22 bytes, put it in data, and the location will be size of settings minus 23. We can enable config just in case it's not enabled, and then we can write to the same byte where we read the calibration, which is 55, and we write the 22 bytes we have in data. Okay. After that, we're good to go. I didn't like this one for some reason. Is that? Yeah. It's the same one. If value equals 1. Let me compile, see what errors come up other than that one. So I have a few of the same ones. It's only one. So I value, somewhere in here I have a misspelled value. Let me see what that is. Where is that coming from? This is just value. Expression must be a modifiable L value. Now I'm confused. All right. Well, well, let's just use data and see if that's. Oh, never mind. What am I missing here? Am I missing something? No, location. We're missing the. Oh, okay. This is incorrect. We're missing something here. So side value is asking for the size. It'll be 1 byte, and then it'll be size of seconds minus 23, 24, not 23. So that will correct this one. It should correct the bottom one as well. Still not liking it. Oh, that one. You had an assignment operator instead of something to compare it. Okay, so we're good. So as a way of knowing if it's calibrated, we're just going to use the LED, the onboard LED on the Pico, and we'll set it to on, just 25, 1, when it's not calibrated, and if it's calibrated, we'll set it to 0. So we have to initialize this, and we have to initialize it before resetting it. So GPIO init 25 and GPIO set direction 25 equals 1 for output. Okay, let's compile one last time and let's go use it. Let's see if no other errors come up now when we try to use it. So we added this at the beginning. So now we can instantiate BNO, call it gyro. And it's an I2C port. We're using port 1. The address is 29 for the BNO. And the SDA will be, we said it was going to be 14. 14 for SDA and 15 for SCL. So SDA is 14 and 15 for SCL. We're good. Here we say gyro get data. And if we did everything correctly, we're just going to send the data at the beginning. So let's we'll use the phone to send a message. And let's call it roll equals an integer, and it'll be gyro roll. Let me compile. And there are errors. This is what I think this is. Yeah, so every once in a while, in this platform, I'll run into when I'm doing C++, I'll run into 1 or 2 functions that for some reason they compile in C, but in C++ they give me issues. So this is in line 182 of the BNO55. Let's go to 182. Those. So it's likely both of them, since those are the same, coming from the same library. So we're going to use this one. We'll select it, press F12. We'll go to the definition, and we're going to copy it. So this is a workaround. So I'm going to add a file, a C file, under source, and we'll call it helper C. And we'll paste that here, and we'll include hardware and flash .h. And let's change the name of this one. So flash program, actually flash settings, so it's more in line with our stuff. Okay, and we'll copy this to our BNO, go to the top here, and say extern C. We'll leave it there so we can call it. Let's go look for this. So now here, instead of calling this one, we'll call this one, put it here, and we're gonna call it flash settings. Okay, move this one to the top as well. Now I can take this two and move them to the helper C file, put it here, and just make sure that the variables align, or the parameters align. This is the data, and this is the count, and we're going to CMake lists at the file src helper.c. Okay, so let's compile again, see if we still get errors. We'll probably still get errors. Oh, no errors. All right, we're good. So now we go to main. Let's compile again, and let me connect. Let me switch my view so you can see my unit here. Make this small. Actually, let me just hide it. So let me power this up. And I have this ready to go. So I have a configuration for that specific setup. So I have calibration data, all the components. I have the flag, a button to press to calibrate, heading, pitch, roll, and then a console. So it's connected right now. You can see on the blue LED, that means it's connected. If I wasn't, it would be blinking like that. So let me connect. Okay, and let me reset. Okay, I will drop the file, and if everything's good, we'll get data here. Right, there's the calibration data. Right, it's not displaying anything there because those take special names, field names to send it. So let's do that now that we have calibration, not calibration data, but orientation data. So let me enable my code again so you can see the changes. So we'll need to go to the BNO. Let's get the components of this as well. So now that we're here, we'll get that one, and it will be 0, 1, 2, 3, 4, 5, 6, 1, 1. This will be the magnetometer calibration data. 4. Now, let me switch here. So if you recall, the calibration has 4 components, right? Each 2 bytes, each 2 bits, not 2 bytes. So here's the first 2, and then here's the next 2, and next. Okay, so let's go back to the code, and we'll add 2 zeros, 4 zeros, and 6 zeros. And we'll remove 2, 4, and 6. We'll shift it 2 bits, 4 bits, and 6 bits. And we'll change the name to, what is this? Accelerometer, gyro, and system. All right, so I think we have enough data to display, so we'll go to this one. And we'll add the heading first. That's to have a delimiter, a column delimiter. And we'll add the first 3, 1, 2, 3. So this one will be heading, gyro, roll, and the pitch. So we'll need the roll and the pitch. Let's compile. We'll switch to view. Put it right here. A little more. Okay, so you put it here so everything will be visible right there. Okay, let me reset it. Drop it in. Let's see what we get. So now we have got data on those three, I think. So there's the heading. You can see it turning, the pitch, and the roll. So that's the pitch, the heading, and rolling. Okay, let's populate the other ones at the top. Okay, so for the other ones, let me add a space here. So we need 1, 2, 3, 4, 5, 6. No, 1, 4, 5, 6. We need 6. Wow. So 1, 2, 3, 4, 5, 6. And for those 6, we need the calibration magnetometer, calibration accelerometer, calibration gyro, calibration system, I think. 1, 2, 3, 4, yeah. And then we have the calibration flag and calibration data. So I have 1, 2, 3, 4, 5, 6. 2, 4, 5, 6. Okay. So we'll start with. Let me get this on the next line. So gyro calibration mag, and we'll copy this. One more. So that's mag, accelerometer, gyro system, and then the calibration flag will be calibrate, and the calibration data will be calibration data. Let's compile again. Let's see if I get any errors. No errors. Let's move this side of the way. Reset it. And we should have information here. So now we have data there. You can see this one calibrated already. If I move this one, well, that's one calibrated. This one has not for some reason. Okay, this one has a 1. Let me move it. Okay, so the mag is not calibrating for some reason. It will be this one. So let's see. This one's not calibrating. Let's see. Am I overwriting this somewhere? Go to main. Oh, it's not showing because it has a space here. I put a space there as a way to tell where I was. So let me compile again. Let me move this. Reset it. And we should start getting data there when I shake it. So there's a 1, right? You should get data there when I put it here. There's a 1. And if you look at the LED, can you see it? There. So the LED is on because it's not calibrated. So that means that if we press calibrate, well, it doesn't do anything because we haven't added the code for that. So let's add the code for it. And this will be in main. At the bottom where we're checking phone messages, we'll say if str compare phone field name is equals to the data we're sending. The field name is called calibrate, and if it's equals to 0, that means we found a match. Then we can say gyro calibrate equals phone field value. So let's compile again. Move this to the side. Actually, let me hide it. Reset it. And drop it. Okay. So if this is working when I press it, it should pause for a second and then continue, and all of these ones will clear at the top. There, so they clear, right? So now I can calibrate. So let me move this here to the side so we can see it better when it's calibrating. Let me move my camera a little bit. And so calibrate, and to calibrate, you let it sit still until this one turns to 3. Then you calibrate the accelerometer. It has to be done in that order. So you put it at an angle until it turns to 1. There it is. Another angle until it resets to 0. And then you hold this thing at a different angle for 2 seconds. And then at a different angle for 2 seconds. And then it should turn into 1 again. And then it'll turn into 3. And now you have a calibration. And to calibrate the match, you just shake it. And there it is. Now it's fully calibrated, and you'll see this is going to go to 3 in a minute. So, well, sometimes it doesn't. So it calibrated because it turned off the LED. I don't know why it went to 63, but in any case, all 3 are calibrated. So that means that if I did everything correctly and if it truly calibrated, it should go to the top, right? See, fully calibrated, it kept it. So it doesn't matter if I disconnect and go back at it, there's nothing there, and I connect. We have a full calibration from the beginning, and if I wanted to calibrate again, same thing, you press calibrate, it'll reset, the light comes on, you wait for this one to turn 3, turn at an angle, so acceleration turns to 1, then resets to 0, hold it for 2 seconds, there should be nothing, another 2 seconds, there should be nothing, and then at an angle there should be a 1, at an angle there should be a 3, shake it, and we have full calibration, and you see that the light went off. Right, so if I reset it, it goes to full calibration. If I power off, power back on, we have full calibration. So that's it. I will upload the files for you guys to download, and that concludes the demo. Actually, before I do that, now that we have this, we can test the gyro to send data to this guy. So when we rotate it, this will move like on the previous video. So let me move this out of the way. And let me add the line required for this. So let me show the code. And since we have that class already, all we need to do is here, we'll just say NRF send message, and the message we're going to send is message. But so is this one here. So we're going to copy into message. We're going to copy the role. So it will be an integer, and it will be the gyro role. And because it requires a couple of special bytes, I have to do it this way. So byte 30 should be an R, and 31 should be an O. And I'll compile. Let's make sure everything compiles correctly. Okay, so let me hide the code again. And let me send it. Let me put the phone right here. You see it, reset it, send it. Okay, so it's going. Let me power this up so we can have this thing move. Let me hold it like that. So the servo requires 12 volts. The servo driver requires 12 volts, not the servo. The servo is 5 volts. So we'll power that up. Okay, you saw it move a little bit. So if I move this, now this thing is getting gyro or orientation data, sending it to the phone, and sending it to this one as well. So that concludes the entire demo pretty much. It's a gyro cam. Obviously, I'm not doing the servo for in the Pico yet, but I'm doing it on a different processor, an STM32. But that is the demo here. I wanted to show something else. I just don't recall what it was. So I think we might leave it like that for now. Let me see if I remember what that was. Nope. Nothing comes to mind other than here is the demo. By the way, because we're in full NDOF mode, even though it's calibrating, it'll continuously calibrate. So it'll start, if I reset it, it'll start at full calibration and then it'll continuously calibrate whenever you sit still. So this is just to get started right away with good data, and then it'll just keep going from there. So, oh yes, now I remember what I wanted to show. So before I disconnect, you see that the this information is all full value, full numbers. That's because the Pico doesn't do a floating point. So a workaround would be, and I'm just going to do the roll, not all of them, just the roll, because it's just additional calculations that I really don't want. So roll decimal, and then we'll go to where we get data right here. So if I wanted to get the decimal, I could just multiply this by 100, and then here I can say roll decimal will be actually it's like this. So ABS roll modulus 100, and then roll 100. And let me compile this. Okay, and let me hide it since we don't need it anymore. We'll reset it. And then you're going to see the roll now have a decimal with data in it. So, obviously not yet because we need to send it. Where's the roll? Right here. So on roll, we'll put a dot and another variable here. So after roll, we'll get decimal, gyro decimal right there. Compile again, make sure there's no errors. We'll reset, drop it. And so there's the roll now with decimals. So if I rotate this, right? And is this, so if I move this one, obviously the roll moves with it. So, it's not on a flat surface. So, all right, so there you have it. Here it is. Enjoy.